Hi, my name's Amanda, and today I'm going to show you how I built this dartboard cabinet. Now, I did use plenty of traditional tooling on this project, but I also relied heavily on the Shaper Origin to cut things like templates for this bending form, milling brass, cutting cork. We're going to go through all those techniques. I'm going to list all the materials you need in the description below as well as throughout this video. But let's get started with the first step, which is one of my favorite methods of milling, called rip and flip. So when I designed this piece, I originally intended for the doors to have this really intricate pattern, which ended up being a total failure, and you'll see why later. Because of that, I wanted a nice quiet grain, super straight, nothing distracting. So I bought maple 8/4 flat sawn and rip and flip that material into quarter sawn. It yields really nicely, it ends up being super clean, non-distracting, and it also gave me control over the rails and stiles on the door. So if you look really closely, the rails and stiles are book matched to each other, which was a little bit of extra effort, but I think is nice in the overall appearance. Another nice thing about rip and flip is you're able to yield the thickness of material that you want. So even though I could technically have gotten a quarter sawn maple board 5/4 rough to yield the casework and the door material, I was able to get nice quarter sawn material out of 2 boards, same color, thin enough to veneer the top of the bent kerf case and the 1/2 inch case around the drawer. You rip your material 1/8 inch over whatever you need, edge join each side, glue those up, and mill it to your final thickness. The entire piece is made out of maple, aside from the kerf bent top, having a poplar core and maple veneer. And I made shop sawn veneer and seamed it myself, which I'll be showing you later in this video. But let's continue with the sides. One trick I've used since I started woodworking is when I lay out my panel for glue up, I mark a triangle on the face and I mark in and out on each edge of a joint. So when I go to the joiner, if it's marked with an I put that face in on the joiner fence, and the next board I do out. And what that does is it corrects whatever out of squareness the joiner fence may have and creates a perfectly flat panel, especially when you're gluing up multiple boards. I roughed out all my parts and just focused on final dimensioning the sides and the bottom of the case, because we really can't decide the final size of the doors till the case is put together anyway. Just focus on those, and then next we'll move on to the kerf bent top. So I'm going to say this over and over probably, but seaming veneer is probably one of my favorite things. 2, when I was deciding the rip and flip technique, that I wanted to do a similar look for the top. I wanted to also make this accessible, so resawing shop sawn veneer, if you don't have a large capacity bandsaw, there's limitations if you don't have a drum sander, but I've made this to where it's really easy for you to do in your shop. So I resawed my shop sawn veneer out of the 8/4 material as well, so it looked cohesive with the rest of the cabinet. Secure it with double-sided tape to a 3/4 piece of MDF and run it through the planer. So if you don't have access to a drum sander, that's an option as well. All right, seaming veneer. You're gonna want blue tape, but not this stuff. you're gonna want 290 blue tape. And that's because this has a little bit of a stretch to it and it's gonna pull those seams really tight. Now seaming, I like to do on the joiner very carefully. You could do these by hand if you wanted, but I feel comfortable edge joining 1/8 inch material on the joiner. Just very light pass. Doing the same thing, in and out method I mentioned earlier, and then using blue tape to pull those seams closed. Once I've seamed the veneer, I run a piece of tape along the full length of the seam, flip it over, run a bead of glue down the full seam, and kind of work that glue across the seam by folding it in and out. Then you're going to go back in with the tape, stretch the tape across the full length of the seam again, and you're done. And I actually waited until I had a full width veneer to send it through the planer sled I talked about earlier. And you can do this before or after. I did it after because it does leave a little bit of a glue cleanup, and typically I'd sand it afterwards anyway. So that's a really nice option for creating veneer to seal the top and bottom of the kerf bent top of the cabinet. So this bending form is created in layers. You don't need this to be MDF all the way through. It's like heavy enough as it is, but it also just needs to be strong enough to be able to withstand the pressure in a vacuum bag. To do this, you need a router bit that has a top and bottom bearing and at least 2 inches of cutting length. That's because this is built from the top down. So in order to cut this ply and this ply, I need to be able to span those 2 layers, which with 3/4 MDF ends up being 1.5 inches. So I'll link below what I suggest for using this. This is just glued and brad nailed together layer by layer as you build up, so you work from the top down. I just made it a little wider than the depth of the cabinet, and it worked out just great. So I'm going to show you basically the skeleton of this kerf bend. So in order to get this curve, you have to kerf bend on one side of the board. And to get the opposing curve, you have to kerf on this side. So it was a fun little experiment. I had to go back and cut these a little bit wider, if you can tell, to get more of a bend there. I will give you general measurements, but this may vary between your material and mine. So it's something you have to experiment, take in and out of the vacuum bag, and cut a little deeper. But I didn't want to go much deeper than 1/8, because then you run the risk of cracking. So let's talk about the actual glue up on the bending form. So after you've done a few dry runs, everything's looking solid. I like to use some form of netting on the top, the bending form on the bottom, and the glue I like to use is a polyurethane adhesive or Gorilla Glue. The reason for that is it creates a much more rigid glue line. Any bent laminations or bending I typically use polyurethane glue. My form did end up not conforming exactly to the shape I wanted. I could have used a couple cauls to put pressure down on the ends, but it's okay, and this is why. I basically designed this cabinet knowing that there were going to be a lot of variables when it came to the top of the curve. And no matter what, I could tell you the exact way to mill everything to exact dimensions. There's going to be some sort of play. Ultimately, you're going to have to scribe a few of these pieces to whatever the top ends up being. So once that comes out of the form, I trued up one edge on the joiner, the back of the cabinet. It is just tall enough to rip at your table saw. Make sure you cut the top and bottom at the same time, and the shape of the top will allow you to get perfect 90-degree cuts. I should also mention, when you're cross-cutting your top and your bottom, there are 2 French cleat pieces that go on the back of the cabinet, and cross-cut those to length as well. Before this cabinet goes together, I also applied a veneer to the front. I found a piece of flat sawn maple that matched the closest to that gentle curve, and that was done simply by applying that 1/8 inch, I think it was over an 1/8 inch veneer to the front. Then you flush trim on the router table very carefully because it can get a little tippy. I clamped 2 blocks at the base of the top to kind of hold it upright, and that really helped. Okay, now that you have your top, bottom, and sides prepared, we're going to dive into the drawer case, which is on the bottom right side of the cabinet, and it holds a little drawer that will hold darts, notepads, things like that. And it's a very simple process. It's a 3-sided assembly joined together with box joints. I wanted to showcase the fact that Shaper Origin makes it so easy to do box joints with their box joint feature. You simply plug in the thickness, the width of your board, how many pins you'd like, and it will cut both sides of the box joints on the workstation. And so it's a very simple 3-sided box joint case for the drawer. Okay, in this first video, I just wanted to focus on milling and preparing the main parts, the carcass of the dartboard cabinet, so we can focus on the little details in the next video. So in the next one, we'll be covering the door assemblies, back panel assembly, milling brass, cutting cork, and all the little details that the Shaper Origin really helped me with. If you'd like, please subscribe to my channel. This is my first ever YouTube video, so I'd love any recommendations or comments, and I hope you enjoyed.